Okay. Hello,
Okay.
Ed.
Hello, Ed.
Anant, good to see you again. We're doing another one of these podcasts.
Yes,
There'll
it's
never be
been,
an end to them.
it's been,
Yeah,
we are
it's
trying to
been.
get on
We
a
are trying
regular
to get on a
schedule,
regular
but,
schedule,
but
Yes.
but
Ed's busy
Ed's
calendar
busy
keeps getting in
calendar
the
keeps
way.
getting in the way.
Oh, it's me now. It's me. Okay. Good.
Hey,
Hey,
it's been a few
it's
weeks,
been a few
and
weeks,
we are
Yes.
nearing
and we are
the
nearing the
end of the
end
year,
of
but we've
the
got kind
year.
of
But
two
we've got kind of
exciting
two
episodes
exciting
coming up,
episodes coming up,
including, of course, the
including, of
one
course, the
today.
one today.
But as always,
But as
before we
always,
get
before
started,
we get started,
Ed, why don't you
Ed,
just
why
set up
don't you
what
just
the
set up what
topic for
the
today would
topic
be,
for today would be,
and then we can
and
dive
Sure.
then we
into
can
what
dive into
exciting
what
things we have
exciting
heard
things we
over
have
the last
heard
couple of
over the
weeks.
last couple of weeks.
Great. Well, we are returning to one of our favorite topics. Some of the stuff that we teed up with Kate Blair a few months back in terms of human-computer interaction, and now an interesting turn on that, which is computer-human interaction, and we're going to find out exactly what that means when we bring in Joonas in a little bit. So we won't spoil any of that because I think that'll be a fascinating conversation. But yeah, it's even though last week was Thanksgiving, and you would expect that not a lot would have happened, at least between our last podcast and this one. It seems like there's been a lot of interesting announcements for us to catch up on.
Awesome. So why
Awesome.
don't I
So
begin
why don't I
first
begin
with,
first with,
at least maybe not
at least
last
maybe
week,
not last week,
but a few weeks before
a few
that,
weeks before that,
all the excitement
all the
around
excitement around
Gemini.
Gemini.
Sundar
Sundar
Pichai
had an
had an
awesome
tweet
tweet
which said
which said Gemini with an I followed by an I followed by an I.
and either
And
he's
either
absolutely
he's
brilliant or
absolutely
his PR
brilliant or
people
his
are
PR
absolutely
people are
brilliant, but it's
absolutely
really,
brilliant, but it's
really,
really,
really good.
really
And
good.
obviously Gemini
And
is
obviously
getting a lot
Gemini
of
is getting a
attention,
lot of
so
attention.
so we can probably
So we
have a
can
separate
probably have a
conversation. But
separate
what
conversation.
caught
But what
my
caught
attention
my
though
attention though
was
was
perhaps
perhaps
Gemini was
Gemini
proving
was
that there's a
proving
way
that there's
to
a
kind
way
of break
to
the
kind of break the
stranglehold
stranglehold
of
of
GPUs
GPUs
because
because a lot of the
and everything
training
else was
and
done on
everything else was
GPUs,
done on
which we had
GPUs,
already
which you'd
known,
already always known.
But then what caught my
But then what
attention
caught my
was
attention
that
was that
Google is going to make
Google is going to make
GPUs available,
GPUs available,
for example,
for
for
example,
Meta.
for Meta.
And therefore, it's
And
really
therefore, it's
interesting
really
that
interesting that in spite
what
of
we've always
what we've
felt is
always
kind of
felt
the
is kind of the
hardware
hardware
leadership of
leadership
NVIDIA
of
and CUDA
NVIDIA and
leadership
CUDA
from
leadership from a developer perspective,
that there is a
that there
chance
is a chance
for
for
somebody
somebody
else
else
to
to
actually
actually come on the scene.
Yeah. No, I think that makes. I think it was a very, very interesting development. One of the things that I think is ends up being very interesting to watch has been, a lot of the innovation has been driven with general purpose in the case of GPUs, right? These have long since evolved from being general purpose, or excuse me, from graphical processing to general purpose compute, specifically, obviously for mathematical operations, but bringing a lot of stuff, into the mix, and we know a lot more about both training time and inference time compute than I think people fully understood, say a decade ago, and so it is interesting to see some of the activity that Google is taking, and a lot of other folks in the space. But obviously, Google is an interesting player in that they have that integrated stack, and so yeah, I caught that as well, and thought that there was interesting area for us to follow up on.
Exactly, and
Exactly, and we've discussed in the past. I mean, we are all kind of software people,
where
where
the OS
the OS kind of abstracts the hardware away for us.
and we live
merrily in that world, including, for example, the restriction we'll have today.
But the fact of the matter is
that
vertical
vertical integration
and or
hardware optimization all the way through
is something
that is clearly happening in this space too. So we should devote some parts of
some future
podcasts on both what's happening at kind of training time
and
what's happening at inference time.
IBM, for example,
announced a partnership with Grok,
which is
focused squarely on
the inference time.
But there's lots and lots of other interesting things happening.
So that's just something that we should take our listeners. There may be hopefully there's more than one.
Well, I think we're going to, I think that the long and short of it is we are going to see a lot of, first of all, I think we'll see a lot specifically in that area. And obviously, NVIDIA and the hardware they provide and the chips they provide continue to be foundational, but will be, but as the demand grows, and more importantly, for me, this is sort of the optimization path, which is we've seen time and again in other domains, which is, eventually you find that there are specific areas where there's a huge amount of benefit in terms of going and being able to special case things and get performance optimization. This is true at the software level too. And probably not true, probably even more so. A lot of the software that's running these models and there's been a huge amount of optimization lately, which is why you can now run these models, whether it's GLM or Kimi or any of these others. Like, why can I run them on my on my desktop or my laptop? And it's because you've seen this optimization path. But I think you're going to see that up and down the stack.
So that's
absolutely awesome.
Fantastic.
Let's see whether
you can
pretend
to be
a hardware and stack optimization expert before I can be.
But both of us
will try to pretend that.
Yes, we can certainly play experts on TV or podcasts.
I keep reminding everybody
that
I'm a doctor.
I'm not the kind of doctor that will save anybody's life.
I am a doctor in real life.
On an airplane.
Oh my God!
When somebody suddenly had at 30,000 feet, when they have a database consistency crisis.
Oh, that's right.
We have
trained
you also on that.
Hey, ChatGPT is 3 years old.
Yes.
What's your view there?
I mean, it's amazing that it's only been 3 years, and I think people will probably. One could probably do a thing and do you remember the first time you saw ChatGPT? Just like so many other things,
I wrote haiku. Which I didn't understand, but I asked her to explain it to me too.
But
yes.
I had it impersonate an 80s computer basic interpreter, and had it write a 3-line or 10-line program. It was a very short program. Actually, no, I wrote the program and I had it interpreted. And that was really interesting because at the time, all of the experts, so-called experts who were not actually working in LLMs, said that wasn't possible. They were like, oh no, it's seen a similar program and it is interpreting it in that way. And I was like, no, look, it's arbitrary. I can make these changes, and it does the right thing. This was something that then, Microsoft Research wrote like a lot of people were like, that's flat out wrong. And then Microsoft had written that research paper, the Glimmers of AGI, where they actually, they actually went into depth. They proved just how long. I believe it's 3 years ago, but they showed they did the experimentation with lots of Python programs of arbitrary length, and they were proving that the model actually which in hindsight is not that surprising that a language model can focus as can function as a language interpreter, but it really was something that was causing a lot of heartache for people who were really stuck on the stochastic parrot label, which a lot of people were just very dismissive of at the time. But 3 years later, we're still doing our shtick, which is the important part.
A lot of my programming is also stochastic parrot.
Well, yeah. I mean, after all, or copy and paste from Stack Overflow.
Oh yeah. Hey, we've got lots and lots of other things to get into.
Yes.
There's a lot of exciting things happening in MCP land.
But
Tell me.
Well, I just spent a minute on that one because it's one that really was I think super interesting, that got announced just before Thanksgiving, which was MCP apps. And basically what most people imagine with MCP is that well, first of all, I mean, probably only people like you and I actually imagine anything about MCP. But
most people who talk about MCP imagine.
Yeah, okay. Exactly. We should do that.
Let's do Bayesian. Let's do Bayesian.
Yeah. But generally, people have been thinking about it in terms of saying, okay, let's expose a set of tools, and so
Yes.
MCP has become very important for really sort of that integration of essentially API calls in various forms into the model, as well as being able to supply some other things as well, context and resources. But one of the interesting things that we've seen has been that people end up needing to go, and even with MCP, they end up going and having to build their own chat client, because what happens is they go and they build things where they say, let me have access to a bunch of data. And then they say, well, I want to display that as a graph, or I want to do this, or I want to do that, or I want to, provide some sort of user experience. And by the way, this will dovetail into the next section. But some of the pieces around that, the question becomes, where does that come from? And so now what's going to happen with MCP is that there's standard mechanism by which MCP can provide user interface components, HTML fragments and such, that can actually be rendered into the chat window. And so that's going to make it much more possible to deliver a more full user experience via these MCP plugins. And so I think that this is going to be a pretty big deal for where MCP goes next, and I think we'll be talking a lot more about it in even in the coming weeks. I think some of the stuff we're going to talk about in a few moments will dovetail or perhaps bring us back to that as well.
No, that's fantastic. Because today, for example, either you're writing some kind of you're taking custom controls of the chat window, or you're asking it to write a Python program that does some pie chart visualization, which also it is able to do really well. But it'll just be very fascinating to see how. So then that Python program comes to the side, as opposed to in my kind of natural interactions, and I've got to kind of foobar and everything. So that's really fantastic. But again, exactly, we human beings are at least a large part of decision makers in enterprises, and perhaps we human beings love to see charts, right? And what is all this kind of raw text that is going to kind of come back?
Other stuff too. I mean, charts is just a good example, because I think that seems to be the one that a lot of people run into, and various types of visualization and interaction. Whole workflows.
Exactly. We'll get into a lot of that. So with that, Michelle, let's welcome in Joonas. Hello, Joonas.
Hey, thank you so much for inviting me.
Okay, fantastic. Hey, listen. I'm going to mangle his name, but Joonas Lehtinen. Okay,
that's pretty good.
I thought you were going to mangle my name.
I'm not going to use that again after that. Joonas, I'll let you mangle my name. Ed is a cheats on
cheats
us by
on
having
us by
a
having a very simple first name and last name.
So
That's all absolutely fine. But I've known
Jonas now
for
close to five and a half years.
5.5 years.
And we were very lucky to have him
as an advisor
to the company that I was part of
called Stepsen.
And
I learned an immense amount
about
what does it take for developers to adopt some things. And that was the angle that we had.
Thank you.
But in some ways, he thinks he's building on that. He'll tell us why. But the new Joonas that I know has been working through all the issues that Ed and I talked about 5 minutes back, which is how do computers interact with humans. So welcome, Joonas.
Thank you. Great to be here.
So Ed,
do you want to kind of set up this flipping between
humans talking to computers to computers talking to humans?
Well, I think you just stated it, but yeah, I think that's been one of the things that we've wanted to talk to you about, Joonas, which is that it does seem like the interaction patterns are flipping, and it's easy to go and say, well, it's computers talking to humans and humans talking to computers, but what exactly does that mean, and what is it that you're seeing that's now changed?
I don't know exactly. Do we yet see that it's changed? I think everybody anticipates that computers are the ones who are running processes and really running systems, and that kind of puts them in a place where they need to be interacting with humans. So we started thinking with the LLMs, could we somehow provide an MCP to a human or an API to a human? What would that look like for the computer? But it started off as a kind of just toying with the idea that we might need to be turning the paradigm of HCI around.
Also, Ed and
Anant are just tools.
Yeah, we are all tools. No, I don't know where this kind of leads, but I'm anticipating that more and more the computers are not the ones who are being. It's not me calling into and asking for help. It will be the other way around when they need the help, if they need the help.
That makes sense. I know that. I think it was Gardner who wrote a thing once that like this was like 5 years ago, 10 years ago, and they were like they're basically saying people are going to be working for smart bosses. Now, what they meant by that was AIs that would tell them what to do, and the idea was that that we'd all be like just basically the way that like Uber works, where you're looking at the app and the app tells you where to go and what to do and so on. So maybe that's maybe. Exactly.
So we went all Matrix from the get-go in the conversation.
Exactly. So maybe that's what we're talking about here is we sit around and we're just an MCP server that like the AI goes and says, hey, Ed, I need you to go and count the number of letters in strawberry because I can't do it. And you're like, oh, here it is. And then it's like, okay, thank you.
If you recall when Ken Jennings lost to Watson, he said, welcome to our computer overlords. So truly, that's what's good. But instead of just kind of talking about that, we'll talk about some slightly more project stuff. If machines are in charge, then how do they interact with humans? And what I loved about it was that I always thought about that as kind of human-computer interactions. And he said, no. In fact, that's in the name of the domains that you have acquired. Is that really we should think about computer-human interaction? So instead of HCI, Chi. So tell us a bit about this shift and what does it mean on that boundary, and what is so obvious to you that is not yet obvious to others, but will become soon.
Yeah. I mean, the background where I'm coming from is building frameworks and components for developers. And the problem solved in there is all about the complexity. So how do we make things in the web stack so simple that developers can be productive and really focus on the building an application or a user interface instead of thinking of a hairy web browser and whatnot. So that same problem kind of is relevant for LLMs at the moment. So if you ask LLM to build you an application, they kind of spend most of their energy in figuring out how do they do security and sending tokens and REST APIs and whatnot. So could we do the same simplification for the computers? So that was kind of where we started from, and then we started kind of shifting into thinking. Could it be? How could we kind of model that the computers could ask permission or advice from humans? Is it just text? Is it just a phone call? Could it be like a video call? Could it be maybe interactive movie that is being generated while you are watching? Could it be AR? So in a way, could the human be experiencing live what the computer is generating, just for the computer to get some of the feedback from the human?
So we saw. So what I saw, for example. We talked a bit about Gemini 3. They talked a bit about something called generative UI as something that. So for example, if I'm my current thing is I'm learning Laplace transforms, which for those of you who care about it is absolutely fascinating. I knew about it, but I'd forgotten about it. And it's just an absolutely fascinating area. But with Gemini, you can actually build an interactive website that doesn't just tell you what Laplace transforms is, but can actually help you learn about it as long as you're kind of prompting and talking about. So I get that stuff. Obviously, amazing amount of work to be done. But in reality, there is also it is not just entertainment or learning. It's also doing tasks and other things, right? So what does it mean for LLMs to actually kind of be symbiotic with human beings and interfaces?
I think this is kind of what Google did was brilliant, but it was the kind of continuation of vibe coding. So in a sense, you asked explain me Laplace transform, and what did it do? It vibe coded a mini app, a web page with some interactions for you. So basically, it was like one zero shot vibe coding exercise, and you got a really nice outcome out of that. But that's quite different from having a conversation with AI. So when you're having a text conversation, then you chat back and forth, and whatever you say kind of shapes the rest of the conversation. So I believe that the interaction then it needs to be continuous. It needs to be something where the conversation flows, regardless whether it is voice or text or user interface. And as our background was coming from Vaadin, the framework, how we had a bunch of user interface components, and then how these connected on the server side. In a kind of a continuous state of the user experience. Users can change click a button, for example, that gets back to your backend application, make some changes on the user interface, and that gets back to your what the user sees. We do the same thing with the LLM. Just kind of scratch the whole backend, scratch the application. Let's say that there is no application at all. LLM is the application, and behind it is a bunch of MCPs. But could the LLM drive that user interface directly? And it turns out it actually works. So the LLM can create you a user interface. It can listen to changes that the user is doing within the user interface and make changes as they go.
And so this is not a hypothetical. You've actually done a bunch of prototyping and building around this. right? Like you guys you're pretty far along on this. It's my understanding.
So it's on a prototyping phase. It's not a product yet. So the big problem that I guess Google team bumped to us as well is that it's a trade-off between how good user interfaces you get and how fast they are. And they took a different trade-off. They took like this, let have computer build your application. So it takes a minute to process, and after that you have a application that responds quickly. And we took different approach. So we don't have an application. So the LLM needs to be processing every event. But it's faster to get started with.
Very cool.
So would you care to show us an example of this?
Sure.
Bring this to life?
Sure. Let me share my screen. Here we go. So, typical tasks that are being done is like seeking approval from a human or seeking guidance or something like that. So let's start from a very simple one, seeking approval. So if we ask the G agent that they would be seeking approval for an invoice, and as a response they get kind of formatted response. This is just a JSON schema for that. And ask them to generate such a UI. They can generate it really quickly. So here is an UI generated by G agent. And if I would be just clicking approve button, this is pretty much the complexity that you would get from the really kind of a basic one-shot approach, like what Google is doing. So you get UI that says that it's approved, and you get the JSON response from there. But if you do it again, let's say, and ask it to delegate, we asked to delegate the invoice. What happens is that the LLM now gets my request to basically it gets an event that Joonas clicked the delegate button. What shall I do? And what it did do is actually figured out that this part of the UI could be replaced, and it generated a bit of changes for that part of the UI. So it didn't kind of generate the new application, didn't generate the new page, and the page didn't have any idea what should happen when that button is being pressed. So if I delegate that to Anant, please approve my invoice, then it should be able to actually send
a large amount. I'm going to reject.
Yeah, I know.
Okay.
But let's do something a bit more fancy, if you will. So let's do something custom. And actually, before that, I could show another example, a bit more complex example. So seeking a guidance.
Joonas, on the previous one, though, how did it know that delegate is a button that should be created?
That is it didn't. It didn't. So what we did was did he really kind of LLM how to speak the language of user interface. It's an old language that we came up 20 years ago for Vaadin framework called user interface definition language. And it has like high-level notation. How do you put buttons and data grids and whatever you want on the screen? So we gave it a mini course in a system prompt on what type of components are there and how you can use them. But obviously we could do a fine-tuning for a foundation model as well to have it a bit more fluent.
Fantastic. But my question was slightly different. How does it know that in the context of invoice approval, delegate is a good button to have?
Oh yeah, that's So in the prompt, I said that there is opportunity for delegation.
I got it.
Yeah. But one thing that is making this quite cool is that if you have a more complex case, like in this case, nurse practitioner is asking for help from a doctor for a patient case, and basically asking which test should we run for this patient. So when we generate this, we just show the case to a doctor, but also we give them a choice of different diagnostics that they can choose. And the And strange thing is that we haven't programmed any of that. So the LLM read through the description and thought that these might be good candidates, and obviously then the doctor can add some more in there. So you can kind of tap into full power of that foundation model with this.
Wow. Okay, so if we go and look at that prompt, basically this was just all you actually put was the basic piece, and with an ask for creating a form for the doctor, and then it used the prior knowledge in the model to go and so that's interesting. So the model participates not just as the coder, but sort of the expert in the loop in terms of helping further define requirements that may not have been anticipated.
So if we do something completely custom in here, just for an example, so this guy I just right up before a podcast. So for hiring interviews, let's have the agent ask some tough questions and score for our screening. And we also need to basically define what is the task, what is the task, but also define what do we want to have as an output from there. That's always defined as JSON schema. In a real application, that would not be generated on the fly. What we want to have here is basically the score out of it. So if we generate the UI, we in addition for having tough questions about AstraDB that I couldn't be answering for, we also get free text questions, and this is like really interesting because you couldn't do this with the normal survey. But here, the LLM will be actually reading my answers and trying to grade them whether I'm a good candidate or not, and then giving back a score.
Ed, will you succeed or fail in this?
Oh, I would definitely fail on this one. Although I think I probably know the answer to the first one. The third one, I would get through process of elimination, and I would fail the free text question.
Yeah, I tried this, and I always got zero score out of this. So. But yeah, it's kind of changes what the user interfaces be quite a bit when you have this smart foundation model that can craft the user interfaces on the fly.
So it's very interesting when we look at these. It raises a number of questions. So first, user interfaces now by definition. So first thing that I love about this is it answers the question in a way that I think people did not expect about, is it going to just be chat? And the answer that I've given in the past is no, actually, you can still have forms, buttons, and so on. But the reason why chat has been durable for model interaction, in my opinion, has just been because of the flexibility. But what you're showing here are examples where the UX itself, even though it is a structured graphical user interface type interaction pattern, is dynamic. Like new UX elements are appearing as part of the interaction, basically as necessitated by the context. So one can imagine this being, for example, part of in this case an interviewing system where the hiring manager may not have been very specific in terms of, or very thorough in terms of what they were looking for in the interview exam, and in this case the model fleshed it out for them perhaps at runtime, and I expect probably you could have that done dynamically based on different steps of the interaction, which is if we ask about these things but somebody had a bad answer in the free text question, you could actually conceivably create some form of pattern which is basically where in your initial context prompt you could have said, based on the answers to the free text question, please if appropriate, ask additional specific foundational questions just to double click on whether they actually understand what they're talking about, right?
Exactly.
Exactly. Yeah.
And this doesn't need to be like a simple web UI. This could be, let's say, SVG graphics. So one thing that, I mean, this use case is more like getting input from human. But if the use case would be more around sharing information, what I'm imagining, and we haven't been implemented this yet, what if it could be creating an infographic for the information? What if I can drill into there just by clicking and touching and the infographics, and it can generate more in-depth drill downs as we go. So it might really kind of create interaction patterns that couldn't be programmed, but it could still be really helpful for you to understand some large data set or really challenging concept.
Yeah, no, that makes a ton of sense.
Hey, what is that?
Hey, what is that?
You went on seek approval and custom task. What is seek guidance?
So guidance is basically for this example where it would be asking guidance for it.
Okay, awesome.
Awesome.
Hey, so fantastic. So we get forms, we get infographics, and everything else. But the scope of being able to interact with human beings, not just interact in terms of one-way interaction, but really interact is tremendously large. Right? You can well imagine generating nano banana images and putting Ed in it and doing all that. So would this run into some limits in terms of structure, that this kind of approach works really well for enterprise contexts where efficiency of information transmission across human computer boundaries is more important than kind of the visual artifacts and others, or this kind of approach is a very generalizable approach.
Yeah, I think this is not feasible yet today. What you see is feasible, but these are not like in real production use. And the challenge is like a balance between how smart the model is and how fast the model is. So, for example, if we use Gemini 3 as a model in here, it's brilliant user interface, much better than this one. But it's so slow that you don't want to really interact with that. After every button click, it takes like 30 seconds or so. And if you put some really fast model in here, really quick to respond, but the UIs are nonsensical. So the kind of I guess the best balance point that we can find today is what we are using today. This is the GPT OSS 120 billion parameter model running on Cerebras inference engine. So that was the kind of I think the smartest model that we could run on Cerebras, and super fast for generating tokens. So that kind of combination gives us this level of
okay, so you are using GPT OSS for this
at the moment, but we have been trying different models. Like GPT 4.1 was pretty good one. This is a bit better because this is faster because on Cerebras hardware. But hopefully Gemini level would be as fast someday, and we could just kind of switch over to that.
Yeah, no, that's I think that is one of the areas where the sort of smaller local models actually can generate a lot, can operate very fast in the decentralized way that makes these types of use cases very well aligned for it. Cool. So let's jump back into the conversation and talk a little bit about where we see this where we see this going next. So you've proven this out on, again, as we said, on GPT OSS. you know, where do you think that the models like Gemini play on this, or that you said that there's still a certain level of performance that you know comes in practice, but directionally, do you see that you know, what are the barriers to or you know, challenges around that?
Yeah, I think right now, if you try this out, and anybody listening, you can go to the computerhumaninteraction.com and try it out yourself. You quite quickly bump to cases where you are not exactly happy how the UI was designed. So the 120 billion parameter model wasn't smart enough for designing those user interfaces. I hope that maybe like somewhere mid next year we start to be having API access to models that are drastically better in UI design, and that way we can make it really practical to use this in some use cases.
Yeah.
So should I think about it then? Joonas, that today, for example, Figma is a tool used by humans, and obviously with bytecoding, now you can kind of design in Figma and have a live site or semi-live site available pretty soon after that. Are we going to get to a point where there'll be some equivalent of Figma used by LLMs? Okay? To design something that appeals to the human, where they enjoy interacting with the computer, as opposed to let me just kind of finish my task and kind of get out of the way.
I think Figma is already providing MCP. So in a way, LLMs can drive Figma. And this is quite exciting to me. And with Gemini 3, I was kind of designing one application, and I was basically having my scrappy napkin design. I took a picture of that, sent that over to Gemini, and then the best design I could do by hand, and asked it to improve it, and Gemini designed much nicer looking UI than I ever could. But then again, I'm not a designer, so it's not that hard to imagine that LLMs can be pretty good in UI design.
Yeah, I mean, I think there's lots of examples where they're not at all that bad. Although there's obviously a lot of debate around that, but it seems like both of those that there's definitely convergence happening at the tooling level. It does. You know, let's talk a little bit about sort of what you know, one of the things you touched on, which is it doesn't always do a you know, a good UI, but one of the things that you know is obviously one of the concerns. One of the things we deal with in a lot of the information retrieval and RAG and so on. We talk about accuracy and so on. How will these dynamic AI generated UXs of the future get QA'd? If the experience is truly dynamic in that level, it you know, will we? What are the mechanisms? I mean, I can think of a few, but you probably have put a lot more thought into it than I have.
If you have thought of a few, please share, because we don't have a good solution for that. So as you say, LLMs, they are kind of random. They if we are asking the same prompt and with this G and ask it to generate another UI, it will be different kind of UI. So it's kind of dynamic on what it's generating. But then again, if you're having a chat with ChatGPT, it's dynamic and random as well. So I think it's the same problem in there. One thing that we did try and are actually using in the demo as well is that it's really helpful to cache the first part of the UI. So if you generate from certain prompt first the UI, if you cache that, you can show it much faster. And by caching that, you can also guarantee that it starts from the same place. So you have a kind of first frame of the interaction is defined. And you can actually use even a UI editor to make little changes for that UI. Like you could have a Figma UI, drag that with Vaadin's designer to Vaadin, and then use that composition as a starting point for G. So all of that is doable. But what happens after that, when the user starts interacting and pressing buttons, there is no guarantee that I can see for that. So we need to be trusting the model, and the model needs then to be quite smart.
Well, I mean, what I was thinking was, I mean, I think we will have to extend the concept of evals to this. I think we're going to need to basically do captures of the screen, or at least alternate renderings of the UX into a saved state that essentially goes through an eval process, and you actually probably do an LLM as a judge type of eval, where you have another LLM look at the UXs and rate them. I mean, you can do it. You could probably do some form of human reinforced stuff too on it. But I think ultimately, I think that's where you end up needing to do. You will have to treat this generated UX just the same way that you treat generated text, and have forms of evals against it.
But there's also that additional thing. It's probably the same thing. But different form factors. So today, if a website moves a button from bottom right to somewhere else, right? It's really confusing, right? I mean, every time my car does a UX change, my head just gets obviously kind of driving at. I'm always following speed limits, so assuming 65 miles per hour. That's the 6 is the first digit of my speed. It's very confusing, right? So some of this is really kind of, whether it's eval or whatever it is taking into account that humans are not that adaptive for kind of rapid changes, and therefore some amount of stability, whether it's through caching or others. Right? So as we shift to something purely dynamic, then kind of bringing some stability for us, mere mortals, is also really important.
It could also be the other way around a bit. In a sense, when you have an application you've been using for a long time and a button changes to different place, it's up to you to figure it out. So there's nobody helping you. But with this kind of dynamic UI, it can be multimodal. So you can just say, hey, I don't get it. Where do I do that? I need to kind of move the button around.
Our computer use model can then click that for you too.
Yeah, or kind of just show that, hey, Anant, here is the button that you want to click.
I get it.
So I actually, I mean, from a UX convention standpoint, that's also an interesting topic, which is that, I mean, you're seeing this in a lot of apps now, which is that they do this chat side pane, and the implementations of those often vary quite a bit, and in some cases work very well, in other cases leave a lot to be desired. But they've got that mechanism where it's like, anything you could do in the UX on the left, you could actually just type into chat and have it do for you. Like, if you're, like if you're in Google Docs, you could go and fumble around to figure out how to change the font size on everything, or you could just go and say, hey, can you make all the fonts a little smaller? And it just does it, which is actually pretty cool.
Exactly. More
dollars to the.
Okay, I get it. Hey, listen, absolutely fascinating. So I'd always come in thinking that humans did everything, and then we started to talk a bit about the fact that humans design interfaces and backend codes are written by LLM. And then we said, no. LLMs can actually generate applications, draw a napkin, and you get that application. But now we are in that mode where it is like completely dynamic and flexible. really the
pendulum is likely to shift.
Maybe
Maybe not as fast as people like you imagine,
but
but
it's going to shift
where
this
this whole world of applications, interactions, and backend systems
is really
really changing, and it's just fascinating how
you have opened our eyes
to the art of the possible.
Yeah, kind of. At least for me, it looks like coding has already changed. Every time when I'm coding, it's less about the IDE and refactor. It's more about chatting with Claude and asking it to do stuff. So in a way, you need less and less of coding tools. It's more of a conversation and high-level thinking where you want it to do.
Separate issue. Okay. Anyway, all perfect. Thank you so much, Joonas. It's just an absolute fantastic. Tell us the story of the surfboard at the back, though.
You can't leave without that one. Vaadin, it's not in Finland. So we have headquarters in Finland, and during the winter time, it's fairly dark in there. So 1 year, I thought, hey, wouldn't it be cool to have more people spending time in California instead of in Finland? So we had this kind of opt-in offsite, very good for a couple of weeks from the beach of Santa Cruz, and go surfing and spend your time during the daytime doing all kinds of fun stuff, and then during the nights code. So I kind of bought that surfboard for that offsite, and my intent was that the guys, when they fly back to Finland, they will kind of take this with them to the end of the kind of office wall, and it will be a nice prop in there, reminding them of that fun trip. But turns out it was too long for airplane, so I inherited that to my home office.
Fantastic. Hey, thank you,
Joonas, so much.
Okay?
Yeah,
Thank you.
That was an
amazing discussion.
Yes, definitely.
Absolutely.
Yeah, so I mean, it's really interesting to look at this UX dimension, and I know, we spend a lot of time talking about this. Certainly, every designer that I talk to who's building these applications is struggling to keep up with it. And I think Joonas's vision, which I think is spot on, really comes to these adaptive, generative UXs in different forms. And obviously the things he's talking about, and we see some of it from Gemini and others. And I think all these things are going to intersect with what I started the podcast talking about with MCPs actually generating or being able to deliver UX, because I think that the obvious component or the obvious implication of this is that those UXs that the MCPs are going to be delivering will be generated. So you'll have an MCP server actually with a set of prompts that determine what UX gets rendered, or the requirements rather than actually hard coded, which I think is interesting to think about. So I'm fascinated by this. I think that this is an area that you don't hear as many people talking about. They're much more interested in getting in at the model level, or what does your agentic loop look like? But this stuff is going to be transformative, and as we were talking about it, things we were talking about, like, how do you debug this? How do you, it's amazing to think about.
No, exactly.
And the other thing that I learned,
right?
For example, right?
So if there's a backend system, we know that there is an
API to that backend system.
And
that gets wrapped in an MCP that takes that API and adds some description, ask me foo and ask me bar.
But in the end, the call to the system is API. Human beings are that much more complex, right? Humans. Right? And yes, you can communicate to me via text. I can respond back. You can communicate to me via speech. You can communicate to me via forms. And
right?
therefore, it is
And
not
therefore,
just
it is not
about
just about
here is some one
here
way
is
of
some one way
communicating,
of
but really
communicating, but really
deciding on if humans
are the tools,
right? That
right?
LLM is
That LLM
orchestrating
is
what's the right
orchestrating
form
what's
of
the right form of
communication.
communication.
And today we saw a
And today
couple
we
of
saw a couple
examples
of
of communicating with humans as tools. And I think
and I think
that
that really it opened my eyes to
thinking of
thinking of us as bots
participating in that
grand
choreography
choreography that
LLMs
LLMs are doing.
Yeah, exactly. Okay, well, this was great. So talk about our next episode.
Yes, so we are going to go from
humans
to
to
not even cells
that make up humans,
but really atoms
atoms
that
make up humans,
and kind of the
quantum
effects out there.
As you all know, if you remember the last podcast I did was with a quantum computer
at the back, and we are going to get absolutely superb experts
in
Alessandro Corioni
and Sarah Sheldon from IBM Research.
And we are not going to
kind of get into the gory details of
quantum computer. We can, but
that would be a short way of having some of our audience fall asleep in the middle of the podcast.
But what we're going to talk about is if the future is really a future where there is kind of fit for purpose computing. CPUs have been fantastic for certain things. GPUs have been fantastic for certain things. And quantum is fantastic for certain things. What is that topmost routing? What is what good for? And therefore, what part of kind of improvement in AI can actually happen through quantum? What part of improvement in quantum can happen through AI? And I've just been kind of blown away with the thoughtfulness of our next two speakers. And that's what our audience will actually hear next time.
Awesome.
Okay?
Well, good. Looking forward to it.
With that, thank you very much, folks. Be sure to thank our crew at the back. Ed.
Yes, of course. We have Michelle, we have Hannah, we have Milan, who have put a ton of work into making sure that we've rolled into this, that we didn't just show up comatose from all of our Thanksgiving food and actually showed up and put on hopefully what people found an interesting events or podcasts. So thank you, folks.
I look like this was actually the best picture that you should have taken, but then I kind of changed it out there. Absolutely awesome, fantastic Ed. Hope to do one of these in person. Maybe the next one we'll do it in person out there. But thank you everybody, and good afternoon, good evening, or good morning, maybe somewhere if you're in maybe in Japan, but fantastic.
Yeah, if you are, hey, we love to see your comments on the LinkedIn. So especially for our audience that's tuning in the morning in Japan or wherever we've determined, Australia perhaps as well. Definitely say hi and let us know.
Okay. Take care, guys. Thank you.